So in this video, I'm going to focus on what are the things that affect the rate of a reaction. So there are 4 factors that we are going to focus on in this course, and these are the major 4 ones that you mostly talk about in chemistry. So now that you have done the thiosulfate hydrochloric acid lab, you probably have some ideas of at least 2 things that we could do to change the rate of the reaction. So think a moment and see what are things that we changed in the thiosulfate hydrochloric acid lab. So there should be 2 things that come to mind in terms of what did we do in that lab. First thing is probably concentration. So we changed the concentration of the hydrochloric acid. We changed the sodium thiosulfate. Both of those we were changing different concentrations by adding them together and diluting them down. Another thing we did in that experiment is we changed the temperature. So in some cases, the students heated the solution above room temperature, and sometimes they put it in an ice water bath to get it colder. Okay. And really the biggest one that we are always going to explore is concentration. That's the one that most chemists can do. Changing temperature, yes, you can do that, but in some cases, some chemical reactions, it's not feasible to heat it up to an extremely high temperature. Maybe that's what you need to do, or maybe it's not as safe to do so. So there are 2 other ones that we will talk about. Next one is what we call particle size. And this one, this doesn't have too much to do with a lot of solutions that we deal with, because with solutions, everything is aqueous. But particle size, you could be talking about solids. When you try to dissolve a solid, you want it in a fine powder. Okay, so the smaller the crystals are, the easier it is going to dissolve. So it's kind of the same analogy here. In order to dissolve something faster, a faster rate, you would see you want it in a smaller size. And finally, the one that maybe you have heard of before is a catalyst. I always spell this wrong. It is a substance that speeds up a reaction. You might know a catalyst in a biological function is an enzyme. Okay, and when you go into biology, you will see that enzymes are a very important part of processes. So I'm going to talk about each one of these, maybe not in the order that I put them here, but each one of them you're going to have to know how it affects the rate of the reaction. So first one is temperature that I'm going to talk about. So temperature, of course, the higher the temperature, the higher the kinetic energy. So as we talked about with collision theory, you're going to get more collisions if you have a higher kinetic energy. So the key word in all of these is collision. So when you are talking about how to speed up a reaction, you must always include the word collision. Okay, so everything comes back to collision theory. So when I ask you questions about this on your quiz, please use the word collision multiple times. Okay, so the faster the rate of the reaction. This also works for opposite. So if I lower the temperature, I have lower kinetic energy, less collisions, and the rate is much slower. Okay. Concentration, of course, if you are in a container and you have more of your chemicals running around in that space, you're going to have more likelihood of collisions to take place. Okay, so the more I have in that solution, the faster that rate of the reaction. That usually makes pretty good sense. Less concentration, less collisions, less it will go slower in terms of your rate of reaction. And again, with both of these, you maybe want to slow down the rate of the reaction so you could see the reaction, because there are some reactions that might take place in less than a second. You kind of want to slow them down so you could kind of record them or take better measurements. But again, the key to this definition is the word collisions. Then we have particle size. Okay. The smaller the particle size, the larger surface area you have, more collisions are going to take place. So again, this analogy I just talked about with, again, dissolving a substance, you want to see that the smaller particle size is always going to be able to spread things out so you get more collisions to take place. So faster rate of reaction. But the big one I want to spend the most time on is catalyst, because that's definitely something we haven't discussed before. So a catalyst is quite unique in the fact that it is a substance which increases the rate of the reaction without being used up in the reaction. So that is why it's a very important substance, that we can use in chemical and biological processes, because it doesn't get used up in a reaction. So how the catalyst actually speeds it up is what it calls is provides a surface area for the reaction to take place. So back to the reaction curves and the top of the curve where we have our activated complex, I use the analogy of a party. So this is essentially providing a surface area for the reaction to take place. So it literally is a place for the molecules to gather. So this is the surface area. And so it is the party place. So it is the place to have the party. So then the hydrochloric acid and the sodium thiosulfate can come in and start the chemical process. Otherwise, they might be bouncing around and don't run into each other. So it provides a surface for the reaction to take place. But then the one thing that it does the best, or the one that you mostly remember, is it lowers the amount of activation energy needed for the reaction to go to completion. So I'm going to draw a reaction curve like you have seen in the previous videos. And for this, I'm going to have my reactant here and the product here. And I'm going to draw my reaction curve. Okay, so this is my reactant, that's my product. So this is an exothermic process. So if I have a catalyst added here, and you typically see this in most books, is it lowers this activation energy. So activation energy is from the reactant to the top of that hill. That's the E sub A, okay, is from there to there, okay? But if I'm talking about adding a catalyst, it's going to lower the amount of activation energy needed. So it's not as big of a hill it needs to go up. So typically what you see is it's like a dotted line. And so this is going to be the activation energy for a catalyst. Okay, so it just lowers the hump, essentially, lowers that hill that you have to go over in order to make that product. So most books put it as a dotted line to show that it's different from the normal reaction curve. So that is how a catalyst gets the reaction to go faster, because it doesn't need to climb that hill as much. It may not be as exciting of a roller coaster ride, but you will make product faster because you don't have that tall of a hill to go up.